Hello everyone, welcome to video lecture series of Computer Organization and Architecture. Today's topic is instruction formats. In this video, I'll be telling you how many kinds of instruction formats are there, like 3 instruction format, 2 instruction format, 1 instruction, 0 instructions, and what are the most common fields which are found in the instruction format. So let us begin. First, let me tell you about the instruction. You must be aware about a computer program. Whenever you are writing a program, means in that particular program, there are certain set of instructions. Means computer perform a task based on those set of instructions which have been written for that particular program. And instruction in a computer, it is actually in the form of the like fields, and fields contains various information. See, what you are saying, whenever you are writing a program means that is a set of instructions, and whenever you are executing the program, it means each and every instruction is being executed. So in the case of the like computer, whenever we are talking, so the bits of the instructions that are divided into groups which are known as field, and the most common fields are operation field, address field, and mode field. So the operation field means an operation code field. It specifies the operation which is to be performed, like addition, subtraction, multiplication, division. Next is the address field. Address field designates a memory address or a part of like processor register, right? And third is the mode field. So mode field, it specifies the way the operand, or you can say that the effective address is determined. Means how operand is to be founded, right? That is what you can tell it to be. So instructions may be of variable length depending upon the number of addresses it contains. I'll be telling you in detail. And generally, CPU organization, it actually falls into one of the three type of CPU organizations. There are three things. Let me tell you. First is single accumulator organization. So single accumulator organization means the operation is done involving a special register which is known as the accumulator. Suppose you are writing this instruction, add x, right? So add x, here x is what? This is the address of the operand, means the add instruction in this case, it actually results the operation. What the operation it carries out? AC accumulator plus M X, and this data, this will be available in the accumulator itself. AC is the accumulator register, and this MX, it symbolizes the memory word which is located at the address X. Second is general register organization, and general register organization means multiple registers are used for the computation purpose. Multiple registers, suppose you are writing, if you are writing add R1, comma, R1, comma, R2, comma, R3. R1, comma, R2, comma, R3. If you are writing this, this is what here multiple registers are involved for the computation purpose. So this is what the general register organization. Here you are adding the content of R2 and R3, and that will be available into the R1. Third is the stack organization. See, stack organization means stack organized CPU, right? It means the work on stack basis operation due to which it does not contain any address field. You must remember here, none of the address field must be available. And for this, you may take an example. Suppose you are writing push X, right? It means this instruction, because of this instruction, it will push the word at an address X to the top of the stack. So address will be copied to the top of the stack, TOS. Now, let me tell you the different types of instructions. So first I'm telling you about the three address instruction. And to understand this, with the help of an example, we have taken an expression x is equal to a plus b into c plus d. And for this, how the three address instructions will be written. So what is to be done when you are writing the instructions means, first what you are going to do here, three address fields will be used. So adding the content of A and B, that will be first operation, then adding the content of C and D, second operation, then multiplying. So at R1 comma A comma B means adding the content of A plus B and copying it into the R1, means this result is available into the R1. Second, add R2 comma C comma D. It means adding C plus D, and this is copied. This result sum is available in R2. Now multiplying R1 and R2 means multiplying R1 and R2, and this result will be available in this particular memory location. It is copying into the X. So this is how the particular operation will be performed, and in each and every instruction you will find three address field, right? So here what we have assumed that computer has two processor register R1 R2, and the symbol, this bracket one, MA or MB, it denotes the operand at that particular memory address. A means personalized A, B means personalized B, means that particular memory location. So the advantage of three address format is, here it results in short programs when we are going to evaluate the arithmetical expressions, but there is a disadvantage also. The disadvantage is binary coded instructions require too many bits to specify three address. So you must remember both the advantages and disadvantages. Now let us talk about two address instructions. Means here two address fields will be used, and two address instructions are most commonly used in the commercial computers. Again, first we have to add A and B, add C and D, and then multiply, because here two address instructions, so you can identify two address. One is related to R1, other is related to A. Copying the content of A into R1. Next, adding B into R1. This is what you can see over here. Already the content of A was available in R1. Now R1 plus B, and the result is in the R1. Third, move the content of C into R2 register, general purpose register. Then add content of D into R2, and the sum is available in R2 itself. Now we have to multiply R1 and R2. So multiply R1 comma R2, and the result is available in R1 itself, right? So in each and every instruction you'll find two address. Now the result which was available in R1, that is being copied into this particular location. So R move content of R1 into X. This is how you can explain the two address instructions. I hope now it must be clear. So the move instruction moves or transfers the operand to and from memory on the processor register, right? And the first symbol which is being listed in the instruction, it is assumed to be both a source or destination wherever the result of the operation is being transferred. And as I've told you, it is the most common used in the commercial computers. Next is the one address instruction. Here in each and every instruction you will be you are going to see there is only one address field. So one address instructions use an implied accumulator register. Implied accumulator register means AC for all the data manipulations. And for multiplication and division, there is a requirement to use another register, second register. And all operations are done in between the accumulator AC register and the memory operand. And T is the address of a temporary memory location which is required to store the immediate result. So now let us have a look for this particular example. This is one address instruction. Only one address field will be available over here, right? So first load A, content of A that will be copied into the accumulator, loading the content into the A, add B, right? So adding the content of B into accumulator, and the result is already available in the implied accumulator, which is AC. Then store T. T is the temporary location, temporary address. So copying the content, this AC into this particular memory location. Now loading the content of C in the accumulator. Add D means adding the content of D from this location into the accumulator, and the result is available in the accumulator. Now first result is available in this memory location. Here we have copied. So now multiplying T means whatever the result is available in accumulator, that is being multiplied with this, and still the result is available in the accumulator. Now store X means from the implied accumulator to this location. So this is how one address instruction you can explain. So all the operations are done between the AC register and a memory operand. And you must remember T is the address of a temporary memory location. Now in the last, zero address instruction. See, zero address instruction means the push and pop instructions will be used. However, there is a need of an address field to specify the operand which communicates with the stack. And here it is also necessary to convert the given expression into reverse Polish notation. So reverse Polish notation is already also required over here, and you know how this particular expression will be converted into the reverse Polish notation. A, B, add this, then C, D, its addition, and finally multiplication. This is the reverse Polish notation, right? And why it is known as a zero address? Because of the absence of an address field in the computational instruction. You are not going to find any of the address field. Push and pop instructions will be used. And TOS, it denotes the top of the stack. See, push A means pushing the content at the top of the stack. Push B, pushing the content in the top of the stack. Now adding the content of these two, A and B. Now again push C means copying C at the top of the stack, then copying D at the top of the stack, push D. Again add C plus D. See, this step is being performed, this step is being performed, and what is next? There is a multiplication. Now at the top of the stack means multiplication of this A plus B into C plus D, and this multiplication occurs and the result is available at the top of the stack. And from this top of the stack it is being copied, means popping the content from top of the stack into this. This is how zero address instructions can be explained. So you must remember that whenever there is a requirement to evaluate the arithmetic expressions in a stack computer, it is always necessary to convert the expression into reverse Polish notation first. Thank you so much for watching this video.